Good morning. This lesson is for my Honors Integrated 1 class and my Integrated 1 class. But before I get started, I want to say I hope that everyone's doing all right out there. I'm not sure how I'm going to title this. I'll title it how I title it in the title. But what I am sure of are 2 goals for the day. Our first goal is going to be to outline how to argue a quadrilateral is a parallelogram. Our second goal is going to go over examples of initial conditions to show that a quadrilateral is a parallelogram. Now, I don't have much written on the board to begin with. I have one question on the board. How would you argue a shape is a parallelogram? I wanted to start this lesson off with just that question. You have the skill set to argue this. You have the argument styles to argue this. But you have to think about what you're going to try to argue and how you're going to get there to accomplish the goal of arguing that your 4-sided shape is a parallelogram. So I would hit pause instead of watching through, maybe jot down a few ideas you have on how you would argue that this shape is a parallelogram. And, as we go through this lesson, see if we agree or if not. But if you at least try this, you have some skin in the game and you'll get a little bit more out of this lesson than just watching it through and writing down what I write and drawing what I draw. So I'm going to hit pause, write out the rest of the first goal, and I'll be back. I'm back, so I hope you had a chance to actually go through and try to answer this question. If you didn't, it's not too late. Hit pause and see if you can figure out a way that you would argue a shape is a parallelogram. So hit pause, hopefully you did. Hopefully you did. All right, well, I'm back. Now let's go ahead and move on with our first goal. How would you argue a shape is a parallelogram? Well, we have to know what a parallelogram does to understand what we're trying to accomplish with our argument. What does it do? What does a parallelogram do? Well, parallelograms have parallel opposite sides. That is what we want to show our shape does. So maybe now that's enough of a clue for you to hit pause and try and articulate how you would argue that, right? We want to try to argue that we have parallel opposite sides. How would you accomplish that? All right, so hopefully you hit pause and tried it. So in earlier lessons, we saw that we could show lines were parallel if corresponding angles are congruent or equal, alternate interior angles are congruent or equal, alternate exterior angles are congruent or equal, or finally, same-side interior angles are supplementary. Only 2 of these work for parallelograms. 2 of these are going to work. And so what I have here is I have a picture that represents each of them. Congruent corresponding angles, congruent alternate interior angles, congruent alternate exterior angles, and same-side interior angles that are supplementary, which is a fancy way to say that they add to 180 degrees. Only 2 of these pictures that I have drawn will actually turn into parallelograms where these angles actually stay inside of them. Okay, so let me erase or add some segments here to show parallelograms or 4-sided shapes. So if I was to add this side and that side, we have this left over, and this is not good enough for us to argue we have a parallelogram. If I do this, and I do this, and I erase the rest, we have alternate interior angles that can be congruent inside our parallelogram or 4-sided shape. This can happen in a 4-sided shape, okay? If I add another segment and then another segment and erase the rest, I don't get congruent alternate interior angles inside a 4-sided shape. So this guy, let me put a big red X. Nope. And nope. Which means nope and nope. And by default, remember 2 of them work, so this will work. And so if I actually drew it like this, this would be a way that I could argue, or potentially argue, that I have a pair of congruent opposite sides. All right. So what I'd like to do is set up a little bit more about the outline of how we're going to argue a quadrilateral as a parallelogram, and then we'll work into actual examples of starting off with initial conditions, congruences, or something that allows us to reach the conclusion that I have two pairs of parallel opposite sides. So let me clean this up, come back, set up the next part of the lesson, and I'll be back. I'm back. I just wanted to add one thing really quick before I erase this and had to record this again. I think it would be easier if I just went an arrow like this. Alright, so now I can erase this and move on to the next section, or the next part of the lesson. I'll be back. I'm back. So let's go ahead and finish our first goal and finish outlining how to argue a quadrilateral is a parallelogram. Remember, I just showed you how to determine if opposite sides are parallel, so let's move on. Now we know we want to find congruent or equal alternate interior angles or supplementary same side interior angles to get a pair of parallel opposite sides. We're going to get congruent or equal alternate interior angles using our congruent triangle argument style. And to get supplementary same side interior angles, we're going to use the fact that the four angles of a quadrilateral add to 360 degrees. I'm going to outline how you figure out if we're going for congruent alternate interior angles or supplementary same side interior angles. Okay, pay attention closely. This is really important to our argument style. When we consider the initial conditions we start with, we have to ask ourselves, can we get congruent triangles by adding a diagonal and or using a hidden congruence? If we cannot, then we must use the fact that the four angles add to 360 degrees. So we're going to try to see if we get congruent triangles by adding a diagonal, okay? So let's go ahead and check off our first goal. This is an outline of how we're going to argue a quadrilateral as a parallelogram, and let's jump into our second goal. All right. So is a quadrilateral with two pairs of congruent opposite sides a parallelogram? Well, I don't have triangles, and that's why we're going to try adding a diagonal. So if I add a diagonal, I'll just say from vertex A to vertex C, do I have congruent triangles? Do I have a hidden congruence that allows me to get that? So why don't you guys take a second, see if you can figure that out, see where the argument goes, and see if you can determine if I have parallel opposite sides. And if you can, that means that this initial condition is good enough to have a parallelogram. So let me clean this up. I will continue with this example. I'll be back. I'm back, so let's go ahead and continue with the second goal. I didn't write much out because if I did, it kind of spoils everything. So let's just go through this and we'll see how this plays out. All right, so we started with two pairs of congruent opposite sides. Can I get two congruent triangles? And I can. We have a hidden congruence, right? We have the side AC is congruent to side AC. So we're going to get congruent triangles by side, side, side. So let's write this statement out. We know that triangle, and I go 1, 2, 3. So I know that triangle CDA is congruent to triangle 1, 2, 3, triangle ABC. We want to make sure that the order of the letters corresponds, that they're in the same position. And this is true because of side, side, side. All right. Now we can list our congruent corresponding parts. Remember, we are looking for congruent alternate interior angles. So let's just focus on the angles here. We don't need to worry about the side. Let's focus on the angles. I know that angle C, I can't say angle C, so I know that angle ACD is congruent to angle, let's see, so it went 3 to 1, so that would be angle CAB. All right, and I also know that angle D is congruent to angle B, right? Those are the second letters. And finally, I know that angle A, I can't say angle A, so I have to say angle DAC let's see, I went 2 to 3, so that's congruent to angle BCA. Now, we have a couple pairs of congruent alternate interior angles, okay? These are alternate interior angles. Angle ACD and angle CAB, those are alternate interior angles for sides AB and DC. And since they're congruent, that means that these must be parallel. And angle DAC and angle BCA, those are alternate interior angles for side AD and BC. And since they're congruent, that means that these must be parallel. All right. So, two pairs of congruent opposite sides are a good enough initial condition to have a parallelogram. Oh, it must be so exciting to watch me, right? All right, so let me give you a visual representation of this. So if I have a four-sided shape where two pairs of opposite sides are congruent, I know that I'm going to get a parallelogram. But in the previous lesson, we saw that a parallelogram made opposite sides congruent. So this is what we would call a biconditional statement. It works both ways. Now, I want to stress one more thing, is now that we have established that two pairs of congruent opposite sides are good enough to result in two pairs of parallel opposite sides, we have another target that we can aim for when we're trying to determine if our quadrilateral is a parallelogram. So now, if we argue that both pairs of opposite sides are congruent, we are now in this situation, which allows us to conclude that we are in this situation. So now if we argue both pairs of opposite sides are congruent, we can also conclude that we have a parallelogram. I don't think that's grammatically correct. We can... And you know, to be honest, I think it's a little bit easier to find the congruent opposite sides than it is to find the congruent alternate interior angles. I see that you guys tend to struggle with that a little bit. So there's two more situations that we have that are conditions that we're going to be able to argue. Well, I shouldn't have said that, but I did. There's going to be two more examples that we're going to see that we can argue that that we can get to congruent opposite sides, and there's one more situation that we're not going to be able to have congruent triangles, so we're going to have to use the fact that the four sides add up to 300, or the four angles add up to 360 degrees. So let me clean this up. I'm going to talk about a couple more situations, and I'll be back. I'm back, so let's go ahead and continue with the second goal. And here are the remaining three possibilities that lead to a parallelogram. The first is going to be diagonals that bisect each other. The second is going to be a pair of parallel and congruent opposite sides. And the third is two pairs of congruent opposite angles. The first two possibilities can be achieved using the congruent triangle argument or arguments. Little clue to show both pairs of opposite sides are congruent. The third possibility, however, let's see if I can make congruent triangles. So if I go to add a diagonal, I have a pair of congruent angles. I don't know if these angles are congruent because I don't know that these sides are parallel. Remember, we're trying to argue that they're parallel. But I do know that I have a shared side, so I have a congruent side, and all that we can actually conclude with this situation is that we have a congruent angle and a congruent side, but we can't get anything else. So remember earlier in the lesson I said that if you can create congruent triangles, then use that method. If not, you have to use the fact that the three or the four angles of a quadrilateral add to 360. So in this case, we cannot create congruent triangles. You know what? I want to make sure I'm not going off the whiteboard. I'm tired of filming this over and over and over again. And I'm on there. Okay. So we have to use the fact that the four angles add to 360 degrees. So remember, we have two pairs of congruent opposite sides, right? And I don't know what the angle measures are. I don't know. But if I called this angle measure x degrees, well, this also has to be x degrees. And if I call this angle measure y degrees, then this also has to be y degrees. And so I can write my equation as x degrees plus y degrees plus x degrees plus y degrees, and I know for a fact that they add up to 360 degrees. But I have two x degrees, and I have two y degrees, and that still equals to 360 degrees. Well, I can actually divide away a 2 because everybody in this equation has a 2. So now I have x degrees plus y degrees is equal to 180 degrees. Well, guess what? X and y, x and y, x and y, x and y, those are same side interior angles, and they're supplementary. So that means that these must be parallel and these must be parallel. So here I've shown that I have same side interior angles that are supplementary, so opposite sides must be parallel. Let's see if I have enough room to write this. I'm sorry I'm blocking. I hope you can read this. Opposite sides are parallel. All right. So again, all four angles add up to 360 degrees. I have two measures of x degrees and two measures of y degrees, and those add up still at 360 degrees. I divided away the two, and I've shown that I have same-side interior angles in either direction, which means their opposite sides must be parallel. Alright, so I'm going to come back, wrap this lesson up, and just give you a bubble chart of what we've achieved. And again, I'm not working this out. I'm going to leave that up to you. Again, it's a congruent triangle argument or arguments to show that opposite sides are congruent. And once you have opposite sides congruent, you can conclude you have a parallelogram. So let me clean this up and I'll be back. I'm back for the last time, I promise. So I wanted to wrap this goal up by making a bubble chart that shows you how the conditions for a parallelogram flow. So both the parallel and congruent opposite sides and the diagonals that bisect each other lead to the first example, which was two pairs of congruent opposite sides, which led us to conclude that we had a parallelogram. So both of these lead to this, and this originally led to that. And finally, we saw that we could not get congruent triangles out of this. That's why it's on the other side. But the two pairs of congruent opposite angles also leads to a parallelogram. But we had to exploit the fact that the four angles add to 360, and then we manipulated the equations to show that we had same-side interior angles that were supplementary, which forces the sides to be parallel. All right, so I'm going to go ahead and end this here. Again, I hope everyone is doing all right out there. Have a great day, everybody. Bye-bye.